Question 1 of this exercise says, solve the following pairs of equations by reducing them to a pair of linear equations. So we have these 8 parts given to us, and in each of these parts the given equations are not linear the way they have been written. So we have to first do some manipulation of the equations so that the equations become two variable linear equations, and then we have to solve them. Okay, so let's start with the first part. So in the first part, the pair of equations is 1 by 2x plus 1 by 3y is equal to 2, and 1 by 3x plus 1 by 2y is equal to 13 by 6. Now, because the variables occur in the denominator, these equations are not linear equations. But if we do the substitutions, 1 by x equal to u and 1 by y equal to v, then what happens is these equations change to, so 1 by 2x becomes u by 2, then 1 by 3y becomes v by 3, and this is equal to 2, and then the second equation becomes 1 by 3x or u by 3, and 1 by 2y or v by 2, and this is equal to 13 by 6. Now this pair of equations is a pair of linear equations in u and v, in the new variables u and v. So let's solve this pair, find out the values of u and v, and from there we can find out the values of x and y. So let's use elimination to solve this pair of equations. So this is, let's call this equation 1 and let's call this equation 2. So we have u by 2 and we have u by 3 in the second equation. So let's multiply the first equation by 2. What does it give us? It gives us u plus 2v by 3 is equal to 4. And now let's multiply the second equation by 3, and this will give us u plus 3v by 2 is equal to 13 by 2. And now let's call this equation 3 and let's call this equation 4, and if we subtract the two equations, the u terms will cancel out because their coefficients are the same. So let's do that. So we do by 4 minus 3. So what does this give us? So the u terms cancel out, and we have on the LHS we have 3v by 2 minus 2v by 3, and on the RHS we have 13 by 2 minus 4. So this is an equation in v alone. So let's solve it and find the value of v. So 3v by 2 minus 2v by 3 will be equal to 6, denominator 6 and numerator 9 minus 4v is equal to 13 minus 8 by 2. So I've just taken LCMs and combined the terms. So this gives us 5v by 6 is equal to 5 by 2, and from here we get v equal to 5 by 2 into 6 by 5, and this is equal to 3. So v is equal to 3, and now let's substitute this value of v into any of these original equations. So let's substitute this into equation 1. So we will get u by 2 plus v by 3 or 3 by 3 or 1 is equal to 2, and from here we get u by 2 equal to 1 or u equal to 2. So u is equal to 2 and v is equal to 3, but our original pair of equations is in the variables x and y. So we have to find x and y from u and v. So x is equal to 1 by u, and hence x is equal to half, and y is equal to 1 by v, and hence y is equal to 1 by 3. So the answer to this first part is that x is equal to half and y is equal to 1 by 3. In the second part, the pair of equations are 2 by root x plus 3 by root y is equal to 2, and 4 by root x minus 9 by root y is equal to minus 1. So clearly these are not linear equations in x and y, and hence we need to do some substitution to convert them into linear equations. So what we can do is we can substitute 1 by root x as a new variable u, and 1 by root y as a new variable v. And what will that do? That will convert the first equation into 2 by root x or 2u plus 3 by root y or 3v is equal to 2, and then 4 by root x or 4u plus minus 9 by root y, so that's minus 9v is equal to minus 1. And now this is a pair of linear equations in u and v. So let's call this first equation equation 1 and the second equation as equation 2, and let's solve this pair of equations using elimination. So we have the coefficient of u as 2 in the first equation and 4 in the second equation. So let's multiply the first equation by 2. So we do 2 times equation 1, and that gives us 4u plus 6v is equal to 4. And the second equation, we let it remain as it is, so that's 4u minus 9v is equal to minus 1. And now we subtract the two equations because that will eliminate the u terms. So let's call this equation 3 and this equation is equation 2. So let's do 3 minus 2. So when we do 3 minus 2, what will happen? The 4u terms will cancel out. On the LHS we will have 6v minus 9v, and on the RHS we will have 4 minus 1. So this gives us 6v plus 9v or 15v, and on the RHS we have 4 minus 1 or 4 plus 1 or 5. And from here we get v is equal to 5 by 15 or 1 by 3. And now that we have the value of v, which is 1 by 3, let's substitute this into any of the original equations and find the value of u. So let's substitute this into equation 1. So we get 2u plus 3v or 3 into 1 by 3 or 1 is equal to 2, and from here we get 2u equal to 1 or u is equal to half. So u is equal to half and v is equal to 1 by 3, but we need to find the values of x and y because the original pair of equations was given to us in the variables x and y. So we have 1 by root x is equal to u, which is equal to half, and from here we can say that root x is equal to 2, and this means that x is equal to 4 just by squaring this relation. And similarly we have 1 by root y equal to v, which is equal to 1 by 3, and this means that root y is equal to 3, and hence y is equal to 3 square or 9. So our final answer, the values of x and y that satisfy this pair of equations, is x is equal to 4 and y is equal to 9. In the third part, the pair of equations is 4 by x plus 3y equal to 14 and 3 by x minus 4y equal to 23. Now these equations are not linear equations in x and y because the terms in x are not linear in x. The x variable occurs in the denominator, and that's why these terms are not linear. So what we can do is we can do the substitution x equal to 1 by u or 1 by x equal to u, and that will turn the first term in each equation, 4 by x and 3 by x, to linear terms in u. So let's do that. So the first equation will become 4 by x or 4u plus 3y. So we don't need to substitute anything for y because the terms in y are linear. So we have 4u plus 3y equal to 14. And the second equation becomes 3 by x or 3u minus 4y equal to 23. So these are the two equations, and these are a pair of linear equations in u and y. So let's solve this pair of equations using substitution. So this is the first equation and this is the second equation. So from the first equation, let's write u in terms of y. So from 1, let's write u in terms of y. So we have 4u plus 3y equal to 14, and from here we have 4u equal to 14 minus 3y, and hence u is equal to 14 minus 3y by 4. Now let's substitute this value of u in terms of y into the second equation. So we get 3u, and instead of u I will write this expression 14 minus 3y by 4, and then we have minus 4y equal to 23. Now this is an equation in y alone, so let's solve this and find the value of y. So we multiply 3 by 14 minus 3y, so we get 42. So 42 minus 9y, and then we have this 4 here and minus 4y here, so this becomes minus 16y, and a 4 underneath all these terms, which I can take to the right side and multiply with the RHS, and this becomes 92. 23 times 4 is 92. So now we get 42 minus 9y minus 16y, or 42 minus 25y is equal to 92, and this means that 25y is equal to 42 minus 92, which is minus 50, and this means that y is equal to minus 50 by 25, or minus 2. So y is equal to minus 2, and now let's substitute this value of y into this expression for u and get the value of u. So u is equal to 14 minus 3y, so minus 3y will become plus 6 because y is minus 2. So 14 plus 6 by 4, and 14 plus 6 is 20, so 20 by 4 is 5. So u is equal to 5, and this means that x, the original variable x, is equal to 1 by u, or 1 by 5. So the answer to this pair of equations, the solution of this pair of equations, is x is equal to 1 by 5 and y is equal to minus 2. In part 4, the two equations are 5 by x minus 1 plus 1 by y minus 2 is equal to 2, and 6 by x minus 1 minus 3 by y minus 2 is equal to 1. So how can we turn this set of equations into a pair of linear equations? So the substitution that will work in this case is 1 by x minus 1 is equal to some variable, let's say u, because that will turn both these terms into linear terms in u, and similarly 1 by y minus 2 as some other variable v. So let's see what will happen if we do these substitutions. So the first equation will become 5 by x minus 1, or 5u, plus 1 by y minus 2, or 1 by y minus 2 will become v. So 5u plus v is equal to 2, and then we have 6 by x minus 1, or 6u, minus 3 by y minus 2, or minus 3v, and this is equal to 1. And now we see that this is a pair of linear equations in u and v, which we can solve easily and find the values of u and v. And once we have found the values of u and v, we can use this set of relations to find the values of x and y. So let's do that. Let's solve this pair. So we'll use elimination to solve this. So if you look at the coefficients of v, the coefficient of v in the first equation is 1 and in the second equation is minus 3. So let's multiply the first equation by 3. So 3 into the first equation will give us 15u plus 3v equal to 6, and the second equation is 6u minus 3v is equal to 1. And now all we need to do is to add these two equations, because that will eliminate the v terms. So let's add the two equations. So what will we get? So on the LHS we'll get 15u plus 6u, so 15u plus 6u, and the v terms will cancel out, and on the RHS we will get 6 plus 1, and this means that 21u equal to 7, or u is equal to 7 by 21 or 1 by 3. Now that we have found u, we can substitute this into any relation and find the value of any of these two original equations and find the value of v. So let's substitute this into the second equation. So we have 6u, so 6 into 1 by 3, that's 2. So 2 minus 3v is equal to 1, and this means that 3v is equal to 1, or v is equal to 1 by 3. So v is also equal to 1 by 3. And now we have found out u and v, we need to now find x and y. So let's use the first relation. 1 by x minus 1 is equal to u, which is equal to 1 by 3, and this means that x minus 1 is equal to 3, or x is equal to 4. So this gives us the value of y of x. And now let's use the second relation. 1 by y minus 2 is equal to v, which is equal to 1 by 3, and this means that y minus 2 is equal to 3, or y is equal to 5. So the final values that we obtain, the solution to this pair of equations is x is equal to 4 and y is equal to 5. In the fifth part, the pair of equations given to us is 7x minus 2y by xy equal to 5 and 8x plus 7y by xy equal to 15. So clearly these two equations are not linear equations, but by doing a certain manipulation of both equations, we can reduce them to a pair of linear equations. So what can we do? Well, what we can do is, for example, in the first equation, each of the terms in the numerator, let's divide it with the denominator. So we will get 7x by xy minus 2y by xy equal to 5. And now what happens? The x terms cancel out here and we get 7 by y, and here in the second term the y terms cancel out and we get minus 2 by x equal to 5. And let's do the same thing in the second equation. So we have the second equation is 8x by xy, and then we have plus 7y by xy equal to 15. And here again the same thing happens. In the first term, these x terms cancel and we get 8 by y, and then in the second term the y terms cancel and we get 7 by x equal to 15. Okay, so now we have this pair of equations, but these equations are still not linear equations. So what do we do now? Well, if we now do the substitution, 1 by y equal to u and 1 by x equal to v, both these equations will reduce to a pair of linear equations in u and v. So let's do that. So the first equation will become 7 by y or 7u minus 2 by x or 2v equal to 5, and the second equation will become 8 by y or 8u plus 7 by x or 7v is equal to 15. So now we have a pair of linear equations in u and v, so we can solve them using any algebraic method and find the values of u and v. So let's use cross multiplication this time to solve this pair of equations. So we have the variables u, v and 1, and we will need to write these equations as 7u minus 2v minus 15 equal to 0 minus 5 equal to 0, and the second equation as 8u plus 7v minus 15 equal to 0. So basically write these equations in the standard form. Now the coefficients are 7, minus 2 and minus 5, so and 8, 7 and minus 15. So b1 and b2 are minus 2 and 7, then c1 and c2 are minus 5 and minus 15, then a1 and a2 are 7 and 8, and then we have b1 and b2 again, so minus 2 and 7. Now let's apply the cross multiplication method to this grid. So we will get u by minus 2 times minus 15, so that's 30, minus 7 times minus 5, so minus 35. So this is what we get under u, and then under v we will get minus 5 times 8, so that's minus 40, and then minus 15 times 7. So minus 15 times 7 is minus 105, and then under 1 we will get 7 times 7, so that's 49, minus 8 times minus 2, which is minus 16. So let's simplify this. So we will get u by 30 plus 35, so that's 65, equal to v by minus 40 plus 105, so that's 65 again, and then we have 1 by 49 plus 16, so that's 65 again. And from here we can immediately arrive at the values of u and v. U is equal to 1 and v is equal to 1. So now we have the values of u and v. From here we can find the values of x and y. So 1 by x is equal to v. This means that x is equal to 1 by v or 1, and y similarly is equal to 1 by u, and hence y is also equal to 1. So the solution to this pair of equations is that x is equal to 1 and y is equal to 1 as well. In part 6, the given pair of linear equations are 6x plus 3y equal to 6xy and 2x plus 4y equal to 5xy. So clearly these equations are not linear equations in x and y because we have these xy terms on the RHS of each equation. So we have to do some manipulation, some rearrangement of these equations so that they can be written as linear equations in two variables which are not x and y. So let's do that. Let's see how we can do that using the first equation. So the first equation is 6x plus 3y equal to 6xy. So let's divide both sides of this equation by xy. So we divide both sides of this equation by xy. So we get 6x plus 3y by xy equal to 6. And now we divide each term of this numerator by xy. So we get 6x by xy plus 3y by xy equal to 6. And now we see that from the first term these x terms cancel out. So we get 6 by y, and then we get from the second term we have the y's cancelling out, so we get plus 3 by x equal to 6. So this is what we get from the first equation. Now let's do the same thing for the second equation. The second equation is 2x plus 4y equal to 5xy, and again let's divide both sides by xy. So we get 2x plus 4y by xy equal to 5, and then we divide each term of this numerator by xy. So we get 2x by xy plus 4y by xy equal to 5, and now from each term we see that the x cancel out here, so we get 2 by y, and then the y's cancel out here, so we get 4 by x equal to 5. So now we have this modified pair of equations in x and y, but they are still not linear equations. So what can we do now? Well, now what we can do is we can use the substitution 1 by y equal to u and 1 by x equal to v, because what that will do is that will convert each of these equations to a linear equation in u and v. So if we do this for the first equation, we get 6 by y or 6u plus 3 by x or 3v equal to 6, and if we do this for the second equation, we get 2 by y or 2u plus 4 by x or 4v equal to 5. So now we have this pair of equations which are linear in u and v. So now let's solve them. Let's use elimination to solve this pair. So let's call this equation 1 and let's call this equation 2. So the coefficient of u in the first equation is 6 and in the second equation is 2. So let me multiply the second equation by 3 so that the coefficients of u become equal. So 3 times the second equation gives me 6u plus 12v equal to 15, and let's call this equation 3. And now what I can do is I can subtract 3 and 1. So I can do 3 minus 1, and what that will do is that will eliminate the terms in u. The 6u terms will cancel out, and on the LHS I will have 12v minus 3v on the LHS, and on the RHS I will have 15 minus 6. So this means that 9v is equal to 9, or v is equal to 1. So we get v is equal to 1, and now let's substitute this value of v into any of the equations to get the value of u. So let's substitute this value of v in the first equation. So from here we get 6u plus 3v, and 3v is 3, so 6u plus 3 is equal to 6, and this means that 6u is equal to 3, or u is equal to 3 by 6, or half. So u is equal to half, and v, so u is equal to half and v is equal to 1. And now what we can do is we can simply find the values of x and y using the values of u and v. So x is equal to 1 by v. Remember that we use the substitution 1 by x equal to v. So x is equal to 1 by v, or 1, and y is equal to 1 by u, and u is half, so 1 by u is 2. So the solution to this pair of equations is that x is equal to 1 and y is equal to 2. In part 7, the equations are 10 by x plus y plus 2 by x minus y equal to 4, and 15 by x plus y minus 5 by x minus 1 equal to minus 2. So clearly these two equations are not linear equations in x and y. We need to figure out some substitution that will convert them into a pair of linear equations. So the substitution that we can do here, we can arrive at that substitution by looking at the form of the equation. So we have 10 by x plus y, and here we have 15 by x plus y, and the second term is 2 by x minus y, and here it's minus 5 by x minus y. So if we do the substitution 1 by x plus y equal to u and 1 by x minus y equal to v, that should convert these equations into a pair of linear equations in u and v. So let's do that. So if I make these substitutions, what do I get? I get 10 by x plus y, or 10u, plus 2 by x minus y, or 2v. This is equal to 4, and then I have 15 by x plus y, so that's 15u, and then I have minus 5 by x minus y, so that's minus 5v. This is equal to minus 2. Now this is a pair of linear equations in u and v. Let's solve this pair using the cross multiplication method. So for that, let's write this as in the standard form: 10u plus 2v minus 4 equal to 0, and 15u minus 5v plus 2 equal to 0. Okay, so let's apply cross multiplication now. So we have u, we have v and 1, and then the coefficients are b1, b2, so that's 2 and minus 5, c1, c2, that's minus 4 and 2, a1, a2, that's 10 and 15, and then b1, b2 again, so that's 2 and minus 5. Now if we apply cross multiplication, what do we get? So under u we will get 2 times 2, so that's 4, minus 5 times minus 4, so that's 20. So u by 4 minus 20 equal to v by minus 4 times 15, so that's minus 60, minus 2 times 10, so that's 20, and then under 1 we will get 10 times minus 5, so that's minus 50, minus 15 times 2, so that's 30. So this is what we get. Let's simplify this and get values for u and v. So we have u by minus 16 equal to v by minus 80 equal to 1 by minus 80. So this is what we get, and from here we can find the values of u and v. So u is equal to, so for u we compare these two terms, so we get u equal to minus 16 by minus 80, so that's 1 by 5. So u is equal to 1 by 5, and we get v equal to minus 80 by minus 80, that is 1. Alright, we have obtained the values for u and v, but what we need to do is to obtain the values for x and y. So from here we can say that u is 1 by x plus y, or x plus y is 1 by u, so that's 5, because u is 1 by 5, so 1 by u is 5, and x minus y is, from this relation, x minus 5 is 1 by v, and 1 by v is 1. So we are still not done, because now we are at a stage where we have another pair of linear equations in x and y, and these are linear equations, both of them are linear equations, and to solve this pair we can simply add these two equations, because that will eliminate y. So if we add them, what do we get? We get, on the LHS we get x plus x, so that's 2x, and the y terms cancel out, and on the RHS we get 6, 5 plus 1, and this means that x is equal to 3. And now that we have the value of x, we can substitute this into any of this equation or this equation and get the value of y. So let's substitute this into the second equation. So that gives us x minus y, or 3 minus y, equal to 1, or y is equal to 2. So our final answer is that x is equal to 3 and y is equal to 2, and you can verify that it is correct. 10 by x plus y, so x plus y will be 3 plus 2 or 5, and x minus y will be 3 minus 2 or 1. So 10 by x plus 1 y is 2, 2 by x minus y is 2, their sum is 4. So the first equation checks out. 15 by x plus y is 3, and 5 by x minus y is 5, and their difference is minus 2. So the second equation also checks out. So our answer is correct. X is equal to 3 and y is equal to 2. In part 8 of this question, the pair of equations are 1 by 3x plus y plus 1 by 3x minus y, this is equal to 3 by 4, and then 1 by 2 times 3x plus y minus 1 by 2 times 3x minus y, this is equal to minus 1 by 8. Now clearly these two equations are not linear equations in x and y, so we have to do certain substitutions that will convert these equations into a pair of linear equations. And to figure out what substitution to do, look at what are the repeating terms or expressions. So we have 3x plus y here, and we have 3x plus y here, and then we have 3x minus y here and 3x minus y here. So the substitution that we can do is 1 by 3x plus y. Why am I doing 1 by 3x plus y? Because I want the new variable to be linear in the equation. So 1 by 3x plus y equal to u, and 1 by 3x minus y equal to v. So this is the substitution that will convert this pair of equations into a pair of linear equations. So what does the first equation become? So 1 by 3x plus y, so this term, this is u, and then we have 1 by 3x minus 1, this is v, so u plus v equal to 3 by 4, and then we have 1 by 2 times 3x plus y, so that's u by 2, because this part is 1 by 3x plus y is, this part is u, so 1 by 3x plus y is u, so we have u by 2, and then we have 1 by 3x minus y, this part is v, and then there's a 2 here, so u by 2 minus v by 2 equal to minus 1 by 8. So these are the two equations that we get. So let's label them 1 and 2, and both of these are linear equations in u and v. Now to solve this, let's use elimination. What we can do is multiply the second equation by 2, because that will generate the equation u minus v equal to minus 1 by 4, and now I can use this equation, let's call it 3, with equation 1. I can add 1 and 3, and that will eliminate the variable v. So let's do 1 plus 3. So by 1 plus 3, what do we get? On the LHS we get u, and u will add, so that's 2u, and the v terms will cancel out, and on the RHS we will get 3 by 4 minus 1 by 4, so that's 2 by 4 or half, and this means that u is equal to half by 2 or 1 by 4. And now that I have u, I can use this value to find out the value of v. Let's substitute this value of u into this equation, into this first equation. So we get u plus v, or 1 by 4 plus v, equal to 3 by 4, and this means that v is equal to 3 by 4 minus 1 by 4, or 2 by 4 or 1 by 2. So far we have concluded that u is equal to 1 by 4 and v is equal to 1 by 2, but what we need to find out are the values of x and y. So let's go back to our substitutions and write equations in x and y. So we have 1 by 3x plus y is equal to u. So 3x plus y will be equal to 1 by u. And what is 1 by u? Because u is 1 by 4, so 1 by u will be 4. And then from the second substitution, 1 by 3x minus y equal to v, we can write 3x minus y equal to 1 by v. And what is 1 by v? Because v is equal to half, so 1 by v is equal to 2. So now we have a pair of linear equations in x and y. Solving them will give us the values of x and y, and to solve them we can simply add these two equations. So let's call this equation 4 and let's call this equation 5. So let me do 4 plus 5, because that will eliminate the variable y. So on the LHS I will get 3x plus 3x, so that's 6x, and the y terms will cancel, and on the RHS I will get 4 plus 2, that's 6. So 6x is equal to 6, or x is equal to 1. And now I can substitute this value of x into any of these two equations. So let's substitute this into the fourth equation. So we get 3x plus y, or 3 plus y is equal to 4, and this means that y is equal to 4 minus 3 or 1. So the answer we get, the final answer we get, is that x is equal to 1 and y is equal to 1. Let's verify if this makes sense. For these values of x and y, 3x plus y will be equal to 3 plus 1 or 4, and 3x minus y will be equal to 3 minus 1 or 2. So if you check the original equations, we have 1 by 3x plus y, so that's 1 by 4, and 1 by 3x minus y, that's 1 by 2, and 1 by 4 plus 1 by 2 is 3 by 4. So the first equation checks out. And then in the second equation we have 1 by 2 times 3x plus y, so that's 1 by 8, and then we have a minus 1 by 2 times 3x minus y, so that's 1 by 4. So 1 by 8 minus 1 by 4 is minus 1 by 8, and the second equation also checks out. So our answer is correct. X is equal to 1 and y is equal to 1 as well. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.